Alright, this video is for Chapter 4, Lesson 8, Exponents and Division. To divide powers with the same base, subtract the exponents. Now remember, in the last video we talked about that if they had the same base and they were being multiplied, you added the exponents. So obviously the opposite now is if you're dividing, you subtract the exponents. So let's go ahead and do this problem. 4 to the 5th over 4 to the 2nd. That fraction bar means division. Okay, so it's basically 4 to the 5th divided by 4 to the 2nd. Now if I were to write this out in expanded form, I would have 5 4s on the top and 2 4s on the bottom, which means if you're simplifying fractions, you just cancel out the same number of 4s on the top and the bottom, and you're left with what you have left, 4 to the 3rd. Well, guess what? Remember what I said about subtracting? 5 minus 2 is 3. So that's how it works. Basically, this is what you're doing. You're subtracting the exponents when the bases are the same, okay? So let's do the next one. I really don't want to have to write out 25x's, and I really don't want to have to write out 18x's. So I'm just going to subtract the exponents. 25 minus 18 equals 7. So the answer is really just x to the 7th, okay? All right, here's the next problem. 10 to the 7th over 10 to the 4th, because if you know the base, I want you to do the math. Obviously, you can't do x to the 7th on your calculator unless you have a really fancy one, and even then your calculator is going to be like, what? So, we're going to go ahead and subtract the exponents. 7 minus 4 is 3. 10 to the 3rd power is 1,000. And again, I can show you how to do this on your scientific calculators if you need me to. All right. Exponents. So, what happens when we have a zero exponent? Earlier, I told you that anything to the 0 power is 1. Here is why. So if I have 3 to the 4th on top, that's that's 3, the 4's minus each other, and you get 3 to the 0 power. Well, if you were writing expanded form, we have 3, 3, 3, 3 on top, and 3, 3, 3, 3 on the bottom. Cancel out all the 3's, and you're going to be left with 1 over 1. 1 over 1 is 1, which means 3 to the 0 power is 1. And this works for everything. 4 to the 4th power over 4 to the 4th power. You have 4 4's over 4 4's. All the 4's are going to cancel out, leaving you 1. And yeah, that means whenever you have something to the 0 power, you get an answer of 1. And that is why. All right, so simplifying expressions. We have 43 to the 0 power. Well, I just got done saying anything to the 0 power is 1. So 43 to the 0 power is 1. All right, 5 to the 2nd over x to the 6th over 5x to the 6th. Well, remember how when we have something and it doesn't have an exponent, there's the invisible 1 right next to it? Yeah, that's where that 1 came from, okay? So it's 5 to the 2nd over 5, which means it's 5 to the 2nd minus 1, which is just 1, right? So then we're going to multiply by x to the 6th minus 6 because we're subtracting exponents there. And we're going to end up with 5 to the 1st times x to the 0 power because that equals 0, remember? Well, anything to the 0 power is 1, so basically it's just 5 times 1, which is 5. Okay? All right, next problem, we have x to the 5th times y to the 6th over x to the 5th times y to the 3rd. Well, the 5 minus 5 for the exponents is going to be 0, which means x to the 0 power is 1. And then we have y to the 6th minus 3, which is 3. So we have x to the 3rd times y to the, x to the 0 times y to the 3rd is going to give me 1 times y to the 3rd. Y to the 3rd is just y to the 3rd. There you go. All right, next set. Negative exponents. Let's talk about this. Let's do the math real quick. So if I were to write this out in expanded form, I would have 3 to the 2nd, which is 3 times 3, over 3 to the 4th, which is 3 times 3 times 3 times 3. Cancel out the 3's. And I'm left with no 3's on top and 2 3's on the bottom, which equals 1 over 3 to the 2nd, or 1 over 9, because 3 to the 2nd is 9. The only thing is if I'm going to use that property I've been talking about the entire time where I'm subtracting exponents, it's going to be 3 to the 2 minus 4. Now, something I haven't said about, it's always the top exponent minus the bottom exponent. Always the top exponent minus the bottom exponent. Don't be switching just because you don't like negative exponents, okay? It's always the top exponent minus the bottom exponent. So 3 to the second over 3 to the fourth is really 3 to the negative second because 2 minus 4 is negative 2. All right? So basically, they are the same problem. 3 to the negative second is the same as 1 over 3 to the second. And that is because when you have a negative exponent, it turns it into a fraction under 1. So the 3 to the second is going to drop down, and you're going to put a 1 over it, so it's going to be 1 over, and then the negative disappears. So it becomes 1 over 3 to the second, where the second is now positive, okay, which is the same. So basically, we're just applying the fact that we know that when we subtract exponents, because we're dividing powers, it's going to turn it into a fraction. Okay, so x to the negative second is the same as 1 over x to the second. Okay, basically it just drops down. If there's still something up there, and I'll give you an example of when that happens. If there's nothing up there, if there's nothing that has a positive exponent, you put a 1 as the numerator. If there is something with a positive exponent, it stays on top. So positive exponents float to the top, negative exponents sink to the bottom, but lose their negative once they get to the bottom. Okay? So another example would be p to the negative third. The negative 3 is going to sink the p to the bottom. Since there's no positive exponent on top, we just put a 1 as the numerator, and we're left with 1 over p to the positive third. All right, there we go. So let's go ahead and do this one. We have 3 times y to the 8th over 9 times y to the 12th. Do you guys see how I turned 9 into 3 to the second? That's because 9 is 3 to the second. It's a perfect square. 3 times 3 is 9. So I can write 9 as a power of 3 to the second power. Okay? So then I've got the rest. And so then, I still have 8 to the 12th. Now I have 3 to the 1 minus 2. Well, 3 to the 1 minus 2 is negative 1. And 12, 8 to the y to the 8 minus 12, it's very hard to say, trust me, is going to give us negative 4. So now we have 3 to the negative 1 times y to the negative 4th. Both of those negatives are going to sink the 3 and the y down beneath the fraction bar. But since there's nothing else that floats to the top because it doesn't have a positive exponent, we just leave it as a 1. Okay? So there we go. There we go. So we have 1 over 3y to the 4th. All right, some more. Let's try writing these without fraction bars. So let's go ahead and do the math. b to the 3 minus 9 is negative 6, which means we have b to the negative 6. And I'll show you in just a minute how to write them with a fraction bar once you have them not with a fraction bar. So I want you to be able to work both ways. Okay? So now we have m to the second times n to the second over m to the 6th times n to the 8th. So we're going to subtract exponents. M to the 2 minus 6 is negative 4. N to the 2 minus 8, that's an 8 by the way, is negative 6. We have m to the negative 4th times n to the negative 6th. And we can write all of these with fraction bars, and I'll show you in just a second. The last one we have is x to the y to the 5th over x to the 5th y to the 3rd. So I'm going to subtract exponents, and don't forget that there's an invisible 1 by that x. So it's 1 minus 5. Remember, it's always the top exponent minus the exponent on the bottom. And you remember, you can only do this when the letters are the same. So you can only subtract the x's. You can only subtract the y's. So that's going to leave us with 4 minus 5 is negative, 1 minus 5 is negative 4. So it's x to the negative 4th. For the y's, we have 5 minus 3, which is a positive 2. So this is going to get a little crazy when I actually turn this into something with fraction bars in just a second. So the final answer for 3 is x to the negative 4th, y to the 2nd. So back to number 1. We have b to the negative 6. Now let's write that with a fraction bar. The negative 6 is going to make the b drop down underneath the fraction bar, and since we have nothing on top, we have to have a numerator. So it's going to be 1 over b to the positive 6th. Okay? For the second one, both the negative 4 and the negative 6 are going to drop the m and the n underneath the fraction bar. And remember, since there was nothing on top, we need to leave a numerator of 1. Now, part 3, number 3 there. This one's a little crazy because it does have a positive exponent. Therefore, it's going to make the y to the second rise up above the fraction bar. It's going to float up. So if it's got a positive exponent, it's going to float above the fraction bar. If it's got a negative exponent, it's going to drop beneath the fraction bar. So the y to the second stays as your numerator, and the x to the negative fourth is going to drop beneath the fraction bar and become x to the fourth. And remember, whenever we have a negative exponent drop beneath the fraction bar, it's going to lose its negative. All right, and you can always go back and you say, well, since this is underneath there, it's really like x to the negative fourth because it's a negative and it's underneath, and then we have y to the second. So it's very easy to go this way and back to that way. Okay, but you got to get used to doing it. All right, I am done. Talk to you later. Bye.